I'm Humphrey Browning. I'm the international sales lead at Deep Secure, and in 20 minutes, I'm going to try and tell you why organizations should consider moving beyond detection-based technologies. And this concept was came about 2 years ago now, where Gartner released a report where they talked about organizations moving beyond detection-based technologies. And they came up with a series of recommendations that organizations could potentially adopt to help them improve their cybersecurity defenses. And we will be sharing the slides after the event, and there's a link to the Gartner report in the slides. But if you Google Gartner and Beyond Detection, you can find the report for yourselves. So Deep Secure are a UK company. We're a wholly owned subsidiary of Forcepoint since July of this year, where they acquired us. We are about 50 people, and we have been working in sort of defence, government, and security agencies for a number of years, and more recently looking at sort of enterprises and critical infrastructure organisations. And we're a software company. We build anti-malware based solutions and solutions to help you enforce policy over content. But today I'm going to be talking more about how you stop malware and how Gartner have recommended a different approach to stopping malware. So what is the problem that Gartner were talking to organizations about trying to stop? Basically, it's as we know, everyone wants to share information, but in order to share information with each other, we have to get it to its intended recipient, and we also need to make sure that the recipient can read what we send to them, or can see what we send to them. And in order to do that, we have to wrap up the information that they want in some carrying data that allows the applications that are going to display that information to the user to display it to them. And it's that process whereby you've got simple business information that's wrapped up in complex data structures that applications need in order to make that information available to you. And that's what attackers exploit. So they exploit the complexity in the application that you're using. So your Office Word viewer, or your PDF viewer, or your PowerPoint viewer. So they are using the complexity in the file formats to find loopholes in the and weaknesses in the implementation, that they can basically insert malware and make programs do things that you don't necessarily want them to do. And so our premise is that if you can somehow separate out the business information that you want from the data that's carrying it to you, and therefore simplify the data sharing, the information sharing, then you've got a chance of stopping the malware threat. And Gartner actually called that process information extraction. And there are a number of organizations that are using this technique as part of their malware defenses. But the issue that the industry is facing, and we are all facing, is that to date, sort of malware defenses have been built on the idea that in order to stop a piece of malware, you have to detect it. And that's not an unreasonable starting point, because that's just common sense, isn't it? That if you want to stop something, you have to spot it first, and then you can do something about it. But the problem with that is that the attackers are very well resourced, and they have been defeating this approach for years, and they've been defeating this approach across a whole several generations of detection-based technologies. And all of those detection-based technologies, they all have a place, and they are, ostensibly they are really good. They can stop pretty much all of the malware in their own way. But the problem is that they each have they can't stop 100% of the malware, and the attackers know that, and they know how to evade them. And now there are sophisticated attacks that can defeat detection-based defenses fairly trivially. I like to use an analogy that if you had a house and all your doors and windows are locked tightly shut and secure, and yet just at the top of the house there's one attic window that you can't keep tightly shut, and the attackers know where that window is, and they're just coming in through it. They're just bypassing all of the other good security that you've got. So what we need is a new and a different approach to solving the malware problem, and that's what we set about doing in Deep Secure. We call our approach, which implements this simplification of data. We call it threat removal, and it sets out to beat the threat of malware without detecting it. And that's a pretty radical thing to do. When I first heard my CTO talking about attempting to do it about 10 years ago, I couldn't actually believe that you could stop something without looking for it, but you can. So what we actually do and what others do is similar, but our approach is unique in all of its elements. So what we do is we proxy information. So if you want to send me a PDF file, or email me an email with a Word document attached, I proxy that information, and then I extract all of the business information from the transaction. So let's say we're sharing a PDF file. I'd pull out all the text and the formatting and the pixel arrays from the images that might be in the PDF file, and I write them into a very simple data structure. So what I'm doing is I'm looking at all of the structure of the PDF file, and I'm just pulling out every object I can that enables me to write it into a simplified form of that structure. So if I had a date string, I don't take the date string. I take the day, the month, the year, the hour, the minutes, the seconds, and I write each of those elements into a very simple object. It's in an XML-like structure, but it's a very tightly typed and encoded version of XML. So I write it into the simplest form I can possibly get it, and that enables me to verify that each of the elements that I've pulled out of the PDF file can't contain anything that's malicious. They can only contain the simple structures that I can verify can't contain anything that is malicious. And I disregard all the rest of the structures that I can't do that to. And that would include things like macros and scripts and anything that's sort of executable in nature, because I can't parse it and simplify it into a structure I can verify. And that's the simplicity of this approach. So I'm taking out the business information, I'm leaving behind anything else that isn't required by the user and might contain anything malicious, and I can verify I've got those simple things. And then if I'm happy with the verification, I build you a brand new PDF file, so it's under my control now, the building of the PDF file, and I populate it with the business information you want. And so I can reliably ensure that you're getting threat-free data every time. And we do this with everything. So we don't have a concept of saying, well, this might be good, this might be bad. We just say, if you want to have this information, then we'll simplify it and transform it and rebuild it, and then you can know that it's secure. So it's a true sort of zero trust approach to data. The independent nature of the verification step and our implementation with this three-stage process allows us to reliably defeat malware, but it all in software. So we can do this, just in software. But actually, we can put the verification piece onto a piece of hardware that gives us even more assurance, because we then everything has to go through a piece of hardware to get into your organization. And we actually built our verification engine on FPGAs. So we have a very simple implementation that doesn't have software or an operating system running on it, just FPGAs, and we can just stream data across those and verify in logic in really fast. And then if we're happy, we'll build you new files. So if you really care about security and you want to force your data through a single point and make the solution non-bypassable, you can do this in hardware as well as doing it in software. Right, so I thought I would just show you what this looks like, because just talking about it can be a bit dull. So I've set up just a very simple demo. It's all in the cloud. I've got a little app that plugs into my browser, allows me to drag and drop files, and anything I drop gets passed to an instance of my threat removal software running in the cloud. And once things are transformed, it will put them into another browser that I can view the transformed file. So here are my my little web app plugins. So I can drag and drop files into here. They'll be uploaded to a copy of my software running in the cloud, and then they'll be passed to another instance that's running in what I'm calling a deep secure network, but and I'm calling this one the sort of internet. So it's simulating passing something from an untrusted environment into a trusted environment via our threat removal software. So the sorts of files that we're talking about here are things like image files, simple image files. So for example, if you want to attack someone, what do? You send them a picture of some pretty cats, yeah? And you can see my Windows image viewer renders that picture perfectly happily. But if I were to look inside that file with Notepad, for example, you can see that we've embedded a script within that image file. So that image that just rendered beautifully as an image also contains a script. And if I were to run this file as an HTML file rather than a JPEG, it'll open a browser and take me out to the BBC website. So let me just show you that. So if I just rename the file as an HTML file, and then I open it again, you can see a browser opening here, and it takes me out to the BBC website. So it's just run that script in that file. Now you say, well, so what? Well, so what is that? Now imagine that you've just gone to a website and this image is on a website. Effectively, the moment you view that image, the attacker's got that payload on your internal system, because this type of attack is not being stopped by traditional detection-based technologies. And once the attacker's got that on your system, they can use, for example, if you're browsing, they could use the Java or the active content on a website to actually then manipulate the file and to release the payload. So I can illustrate how others don't actually see this thing. So I've got VirusTotal running here on my environment. So if I just upload that file to VirusTotal, so you can see there are 58 virus checkers running on that file, and none of them see anything suspicious in the file at all. Interestingly, I've uploaded this file many times to VirusTotal, and it never changes in terms of the result. So what happens when I put the file through threat removal? So let's just do that then. So I'll just upload the file, and it will get transferred across to the sort of other side. So this is now being transformed. And if I download the file, so I can show you the transform file. So here's the transform file. And again, it's still a picture of pretty cats. But when we look inside at this time with Notepad, we can see that the threat has gone. And it's gone because the process has said when I get a JPEG, what I do is I pull out the text and the formatting and the pixel arrays from the sorry, in a JPEG, what I do is I pull out the height and width information, and I pull out the pixel array, and I verify I've got those things, and then I disregard everything else, and then I will rebuild you a new JPEG and put in the pixel array and the height and width information. So one last example of this sort of how sophisticated attacks can be stopped. So steganography is a huge problem in the industry. A lot of ransomware attacks being perpetrated using steganography, and this is sort of hiding information across imagery or other content types. So here's a picture of some cars, kit-built cars that are actually built in a factory just behind our offices in Malvern. And there's nothing unusual about this picture other than it's got the whole of a book encoded in the picture. And obviously, to the human eye, there's no distortion. You can't see any problem with the image at all. But I know that the book is encoded there because one of my researchers put it there. So let me show you just how that works. So I've got a little toolkit here that was used to encode the image with a book in it, and I can pick up the file. So this is picking up the image. I happen to know it was encoded with a password. If I decode it, it's found some data. So I'm going to download the data. I happen to know it was encoded from a text file, so I'll just save it as a text file. So I've just pulled some information out of that image. And if I go back to my folder here, so open the text file that came out. So all of this text has just been pulled out of that image. Now you can hide something like 10,000 customer records in a single high definition image. And of course you can bring in malware. So you can bring in malware using this technique, using social media or something, just hiding things in images there. And then you can exfiltrate data if you've got an insider threat. You can exfiltrate data using this technique as well. And so again, if I just show you that file being going through the threat removal process. So again, if I just pick it up with my little drag and drop tool, it's a reasonably large file. It just takes a couple of seconds to upload, and then it'll get past the threat removal process, and it'll be transformed and dropped into the receiving folder. So here's the transform file. And again, if I go to open this, so here's the transform file. And again, to the human eye, this looks exactly the same as before. But if we run it through my little transformation tool, if I can get back to my transformation tool, so I decode that transform file. And again, I'll just put the password in, run the decode. You can see that no threat was found. And the reason for that, again, is that we picked up the height and width information from the JPEG and the pixel array. And while we've got the pixel array, we can disrupt it just enough that if there were any steganography in the file, we defeat it. And to the human eye, you can't see any difference, but we've made some very minor changes to some of the pixels in the image that have defeated the attack and the encoding of steganography. And it's those sorts of sophisticated attacks that this using information extraction and this technique can stop. If you want to read more about Gartner's recommendations, there are five of them, and one of them is called information extraction. Then, as I say, either Google Gartner and beyond detection, move beyond detection, or we'll be sharing a copy of the slides, and there's a link to the Gartner report in those slides. Thank you very much.